In this tutorial, we're going to see how to draw free body diagrams and how to use Newton's second law. Some guiding questions to draw a free body diagram. So to start with, every object has a mass and therefore experiences a force of gravity in the downward direction. So draw a vector that represents the force of gravity in the downward direction. And you can calculate the value of the force of gravity as mass times acceleration due to gravity. So Fg is equal to mg. Second, is the object touching a surface? If so, then there is a normal force that is perpendicular to the surfaces in contact. Because the object pushes down on the surface pushes back up or holds the object, and that is what we identify as the normal force. The normal force is always calculated by seeing what does it cancel out. Then, is the surface rough? That means there is friction involved. If the object is at rest, then friction is the static friction, labeled as Fs. So static friction can be any value between 0 and Fs max. If the object is at rest but just about to move, that means friction in the system has maxed out, then the friction is referred to as Fs max, and you can calculate Fs max as the coefficient of static friction, which is μs, times the normal force. If the object is already moving, then the friction is called as kinetic, and kinetic friction can be calculated as mu k times Fn, where mu k is the coefficient of kinetic friction. Remember that once an object starts moving, you have to recalculate the force of kinetic friction because it will be slightly smaller than the limiting friction. Then, are there any ropes or cables involved? So if there is a rope or a cable that is pulling on the object, then there is the force called tension that acts along the cable. So tension always acts along the rope. Then, is there a push or pull on the object? Is someone pushing it or pulling it? Then this force can be referred to as the applied force, and you represent it appropriately in the suitable direction. These are the common forces that we have to consider while drawing free body diagram. Other than this, there can be other forces like air resistance. If an object is moving through air resistance is opposite to the direction of motion. So these are our forces to consider. So now let's take a look at an example. A falling skydiver is accelerating in the downward direction at 3.29 meters per second squared. The mass of the skydiver, including the parachute gear, is 67.2 kilograms, and we want to determine the net force and hence the air resistance force on the skydiver. So the skydiver is represented by this rectangle. Let's start with gravity because nobody is exempt from gravity, and we know that gravity is simply mass times g value. And since we know that the mass of the skydiver is 67.2 kg, it's 67.2 times 9.8, which is, why don't you take a minute to calculate what it is? Yes, it will be 659 newtons. So what are the other forces? Since it's not touching any surface, there is no contact force or no friction. We can ignore air resistance. We cannot ignore air resistance on this one because he has a parachute gear. So let's represent air resistance as opposite to motion, and because it's accelerating in the downward direction, your air resistance is going to be upward. So the question is air resistance smaller than gravity or bigger than gravity? How do we know that? The problem says that he is accelerating in the downward direction. So if your acceleration is in the downward direction, that means your net force is in the downward direction as well, which would imply that the downward force must be bigger than the upward force. So we know that we have to make gravity larger than our air resistance. We don't know what air resistance is, but we do know that the acceleration is 3.29. So that gives us a way to find out the net force, because net means total. So the total force is the cos of acceleration. So F net is ma. We know the mass is 67.2, and the acceleration is 3.29. So we can find out the net force as simply 67.2 times 3.29. Take a second to calculate that. Did you get it? 221 newtons? So now that we know the net force is 221, what will be the air resistance? We know that since these forces are in the opposite direction, it is the gravity minus the air resistance, which is our net force. Since we know gravity is 659 minus F, air resistance, is 221. So we can solve for the air resistance force as simply 659 minus 221, which is 438 newtons. So in this problem we kind of worked backward. Usually we know the two forces and then we find the net force and the acceleration. So but here we know the acceleration, so we find the net force, and then you know the total and you know one of the forces, you find the other force.